So without any further ado, let us build Pong in Python. It will combine everything we have learned up until this point. We have made a ball that is a square bouncing around on the screen. We have made a paddle that can move up and down, but not move too far up or down. Stay within the bounds. And the ball can bounce, the paddle can move. All that's left is to combine them. So let's do that today. And wink, wink, this is actually your last programming assignment. So the code that I write today, I will not be giving you. You will have to recreate it yourself. You can watch the video, of course, though. So that will be your final programming assignment in this class, is to do what I did today and make Pong. You can add to it, of course. Make it as cool as you want, but that will be the programming assignment. So keep that in mind. All right, so yeah, we're finally gonna make it happen. Let's do it. Pong. So let's see. Let's talk about, or let's bring in all the stuff that we had from before. Let's go to idle. I guess I'll save this on my desktop or something. Somewhere other than our code from class. So we had paddle, and we had 2D bounce. So both of these programs right now, remember them. This first one, we've got our square bouncing on the screen and a random orientation direction kind of thing. That's perfect. That's good. We need that. That's 2D bounce. The other program was the paddle program, right? That was the one we wrote at the very end of the last programming lecture. It was draw the bounds of the screen as usual. The turtle becomes the paddle. And we have told the turtle to listen for some key presses. Whenever we press the up arrow, it will run this go up function. And whenever we press the down arrow, it will run this go down function. And oh man, does that make for some very nice animation. So you can hold in the arrow key, it'll all work out. But go up will just move the paddle up. And the turtle is the paddle, so it'll end up with a go to as usual. And go down does the same in the opposite direction. The y changes by a negative amount this time. Okay? Is that all coming back to us? So here's that program. And I can press the up arrow and it moves a little bit. Press the down arrow, it moves a little bit. And I can hold it in. And we took great care to make sure with the bounds of the screen and everything that if we pressed up and the turtle was already up at the top, we don't let him go anymore. Same with the bottom. If we try to press down from the bottom, we cannot exceed the bounds of our screen, and we make sure to not move the turtle. We disobey that down key press. So we make sure to stay there with that if statement. Okay? Are there any questions about those two programs? Because what we have to do today is just bring them together. That is our idea. So let's see. We've made sure that the paddle doesn't go out of bounds when it hits the top and bottom. Well, we use the if statement for that. Right? That was this. If paddle y is greater than or equal to 140, bring it back into exactly 140. Same with the negative version of that. Don't go any more with your y more than 140 or less than negative 140. That's too far. And the reason we had to pick 140, remember, was here's my best drawing of a square. Here's our bounding square. Here's the paddle. The turtle is always, or the coordinates of the turtle are always relative to his center. And we remember that the paddle is 60 units tall. And let's see, what else? Oh, no, sorry, the paddle's 120 units tall. Excuse me. And so we can move up or down. This line is y equals 200. That's the top line. This line is y equals negative 200. And for example, if we try to move past the top, where is the paddle in terms of its own coordinates? Because it's always relative to its center. When it's right at the top, well, that is just 200 minus half the height of the paddle. Okay? Half of the paddle is 60, and so it's just 200 minus 60. That's y equals positive 140. And the same thing will be true for the bottom. Okay, so that's how we keep it there. That's how we came up with the number 140. Okay, that's pretty good. We need to combine our programs now, right? We need to combine our programs. The turtle in the 2D bounce program was the square, right? The turtle in the paddle program was the paddle. The turtle cannot be both the paddle and the ball. So we have to do something here. The turtle is the paddle, but the turtle also needs to be the ball. So the solution is your program can have multiple turtles in it. We can make as many turtles as we want. When you say turtle.goto, turtle.forward, you're using the default turtle. There's always at least one turtle in your turtle programs, and Python gives you one. If you want to make extra turtles, you make variables for those. So you say the name of a variable, that will be the name of your brand new turtle, and then you say equals turtle.capital turtle, parenthesis, parenthesis, which is weird. It's a little function, then that creates a turtle for you. It's really a constructor if you've taken CSCI 40. So yeah, that is going to be beautiful. We're going to make two turtles, one for the paddle, one for the ball, and we'll say paddle.goto instead of turtle.goto. We'll say ball.goto instead of turtle.goto, and that will allow us to differentiate. Won't that be nice? So let's make sure I don't already have on my desktop a turtle program. So I want to make a new one. Come on. Come on. Okay, good. So I'm going to make a new file, and you don't get it because this will be your programming assignment. You'll have to watch the video and recreate it. So this will be called pong.py, and I'm going to save it on my desktop. And so I think I'll start with the paddle program. Why not? And let's bring that into pong.py. All right? And so we're going to have to rename everybody. I guess we can keep using the default turtle to draw the rectangle. That's not a problem. But we're going to have to do stuff right here because the turtle can't be the paddle. We need to make a brand new turtle for the paddle. That's going to be our goal here. So yeah, let me just prove that to you. That's all very necessary. Python turtle. It will be turtle, parenthesis, parenthesis. There it is. So make a brand new turtle. This one's been called Joe. You can make as many as you want. Turtle.turtle. I guess, yeah, it's just turtle. Is it not going to show me the exact definition of it? No, it's just like, all right, that's how you do it. Take my word for it, I guess. It really should be here, though. Tell turtle state, blah, 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 turtle dot methods. I wonder where that's defined. It's not on this page. But it is. It definitely is turtle.turtle, I promise. This makes you a brand new turtle, and you can name it something. You can put it in a variable name. Okay? So let's do that. We're going to make a brand new turtle for the paddle. We'll use the default turtle to draw the rectangle. That's fine. Keep that the same. But right here, we need to make a brand new turtle. So let's change that comment and watch what needs to happen. So I'll say paddle equals turtle.capital turtle. That makes a brand new turtle, and it calls it paddle. Okay? And now I can say, instead of turtle dot for the rest of the program, I say paddle dot, at least for the rest of this program. So let's get all that working. Paddle dot shape, square. Paddle dot turtle size. Paddle dot up. Paddle dot go to. See all that? That all is necessary. And paddle dot go to. Paddle dot go to. We can keep the default turtle listing for the key presses. That's totally fine. The default turtle can still listen for key presses. That's okay. But every time we're doing stuff with the paddle, like the go-tos, that needs to be paddle.goto now. It's that other turtle, the non-default one that we're using now. Change its shape, change its color, change its size. And I believe that's everywhere that we were using it. And we'll still use the default turtle dot stuff for the rectangle. So there's going to be two turtles when I run this program now. It's just me copying and changing slightly the paddle program. And in theory, it will all work the same. Okay, definitely doesn't work the same. Almost the same. Interesting. But But you see there's two turtles now. You see the first turtle is stuck, is still drawing the top of that rectangle. I guess we could hide him. And then the other turtle, our paddle turtle, is the wrong orientation. And the reason it's working like this is because the original turtle, when we moved him, he was facing straight up and down. This turtle, whenever you make a brand new turtle, it always faces east. And so this is like facing in a weird direction. We need to change the orientation of our paddle turtle. We got that for free when we drew the box with the turtle before, but we need to change it now. So paddle dot, was it set heading 90 or something? Face north. We need that now. That will set him up in the right direction. There we go. So yeah, there's actually two turtles in our program right now. One's the default one that drew the rectangle, is still sitting there at the end of the rectangle, and then the other one, it has become our new paddle. Okay? So you make a new turtle by using turtle.turtle, and you can assign it to a variable. Any questions about that? I guess just for the sake of aesthetics, we should probably hide this default turtle after we've drawn the rectangle. That's the default turtle. So turtle dot, I assume it's just hide. Let's see if that was correct. It might be hide turtle. Ah, darn. I think it is hide turtle. Got to spell it out. Hide, yeah, hide turtle or HT. Where's the code? Where's the code? Hide turtle. So now we will lose our sad turtle friend up at the top there. So there are secretly two turtles still. Just the first one on the top left has been hidden. All right, so now we're back with our paddle program, which seems to be working out. All right, so that's a good start. Are we still okay? We made a brand new turtle to represent the paddle so that we could have multiple turtles on our program. We needed that because we have to combine the program that had a turtle for the paddle and the program that had a turtle for the ball. So now, yeah, let's bring the balls program into this program as well. Here we go. That was this code, 2D bounce. So, okay, what's the same? Did we keep all of this? There we go. Let's attempt to keep these both on the same screen so I can show you both. So I need to bring all of this code essentially into this new program. So I've got all those still. Draw rectangles, fine. And now we need to do ball stuff. So the turtle, we made it the square. All this stuff needs to happen. I believe all the ball stuff can be done down here. So let's separate our program. Let's be like, we paddle stuff. Cool. And then we'll have we'll do the rest of the stuff down here for ball stuff. All right. And essentially the rest of this program is ball stuff. So let's maybe copy and paste it all. So after drawing the bounding rectangle, it was ball stuff. So here we go. Bring it all in. And so again, it's not make the turtle the square. We need to make a new turtle. Make a new turtle for the paddle. Make a new turtle for the ball. Make a new turtle for the ball. All right, so it's going to be, again, ball equals, you can give it any name you want, but I'll call it ball. Ball equals turtle.capital turtle. Again, it can be a square, pink, stretched out. The width all should be working. And let's see, paddle X and paddle Y, I guess they're not going to clash with turtle X and turtle Y. But just for me, I think I would rather, instead of saying turtle width, I'd rather say ball width everywhere. So let's change this to ball width, ball X, ball Y. That would make me happier, I think. Because the turtle, this is now the ball. And everywhere I say turtle dot in the ball stuff section, it's going to become ball.shape, ball.fill color. Does that make sense? We've made a brand new turtle. We're not using the default turtle for the ball. We're using our own custom one, right? Ball X offset. ball y offset, ball x offset, ball y offset. So just a bunch of changes here to get that working. Put the ball in its correct starting location. We'll deal with that later as well. Ball dot up, ball dot go to, ball x, ball y. There are nicer editors that let you do all these at once, but we're just going to do it by hand. All right, so global ball x, we're changing. Ball y, we're changing. Ball x offset, ball y offset. If ball y is less than or equal to 180. Rein in the balls y. So please yell at me if you see me skip one, because I do not want to skip one. That will be a mistake. We're getting there, slowly but surely. Ball x offset. Bet you never thought changing variable names was so tedious. Draw frame also needs these as global, apparently, so it's all the balls stuff still. Change the balls x by its offset. Change the balls y by its offset. Bounce if hit wall. Ball dot go to. That's what we're moving here, given his new ball x and ball y coordinates. All right. So I believe, if I didn't skip any, that should do it. Let me just scan through everything, make sure it says ball instead of turtle everywhere. But I believe that will do it. And so now I have copied and pasted. We have, of course, the rectangle still. That's the default turtle doing all that. We have our paddle stuff, which we set it up in the right spot, go up, go down. The default turtle still listens for those key presses. That's still fine. And then we make a brand new turtle for the ball so that it can also be on our screen, give it its random direction, and have it move with draw frame as usual. So let's see if that correctly combined them. Get some nice runtime errors otherwise. Yeah, so what did I mess up? So I forgot a turtle x offset on line 83. Whee. Oh, I couldn't even see it. It was ball x offset, ball y offset. There we go. Luckily, Python will yell at us if something wrong happens. And, all right, hopefully that was all of them. Let's see. Oh, yeah. So this is looking pretty nice. We have a ball. We have a... Ball's not moving so super quickly, but we have a paddle. Is anything going to happen? No, of course not. We have to program that. They all just overlap with each other. And that's that. So that's a good start, right? We finally have them on the same screen. Are there any questions about what I needed to do to get to this point? So just to make the game more interesting, let's make the ball move faster. Let's make the hypotenuse length 2 or something. Just multiply these by 2. Let's figure out a nice speed, because that was way too slow. Invalid syntax. Here, 2. I can work with that. An interesting quirk of the turtle program is if you hold in the down arrow and you move the paddle, it makes the ball move slower. There are ways to fix that, but that's beyond the scope of this class. But yeah, the ball's bouncing around, the paddle's bouncing around. Isn't that nice? It's a good start. So, what's missing? What do we still need? I guess we need to bounce off the paddle, right? That still needs to happen. Like, it should have bounced there. And then also, like, we need a way to lose as well. If the ball ever hits the left wall, like, we lost. We should have hit it, right? So we better, like, stop the game, say game over or something. So that is going to be the bulk of our remaining work. Okay? I believe I can close the rest of these. So we're good to go. Does that make sense? That's still what needs to happen. One thing, just to make the game actually playable, let's make sure that the ball always starts on the right half of the screen. So like the x coordinate for the ball's random location, let's make it always positive, because here's 0, 0, right? 0, 0 is right there. Let's make sure the x coordinate of the ball is always positive to begin with, so that we actually have some time to move to it. That will be helpful. So let's start the ball on the right half of the screen. Let's see where we need to change to do that. So the ball's initial x and y are set like this. Let's make sure that the ball's x is always on the right half of the screen, so positive, between 1 and 150. You could also have done 0 and 150, not a big deal, but this will make sure it's on the right half of the screen, of at least of the bounding box. So now when I run it, the ball will always start on the right side. It might be moving left, but it'll always start somewhere on the right side. Let's try it again. Where's the new random location? Yeah, so now it's coming at the pedal. But either way, it's giving us some time to move to it. So that's perfect. All right, so that's fine. Yeah. If the ball ever hits the left wall, it's game over. All right, so we need a way to stop this game. I believe the best way to do it, or the way that I came up with doing it, is let's just stop the animation once the game is over. All right, so we want to keep moving. What is being animated? First of all, it's the ball. The ball is being animated by this while true draw frame loop at the end. If the game is over, we want to stop the ball, right? Stop the ball in its tracks. No more animation. So we want to change this from an infinite loop, which always happens, to a loop that sometimes happens, all right? So I'll make a variable that's called isGameOver. I would like to continue the game while it's not true that isGameOver is true, all right? While this is false, while not isGameOver, you can kind of read it like that. So while it's not true that the game is over, continually draw a frame, okay? And so this is what we can do up here. We can make our variable isGameOver. Definitely false, right? At the beginning of the game is not over. But eventually, if we hit the left wall, the game should be over. So let's set that in the bounce if hit wall function. Global isGameOver, because we might need to change this. So which one is the left wall? Which one of these is the left wall? So if the ball's Y, no, anything dealing with the Y is the top and bottom. This is the left wall. So if we hit the left wall, the game is over. So none of this matters anymore. I guess we could bring it back in. It's not a big deal, but boop. When we hit the left wall. So if we're inside of this if statement, the ball just hit the left wall, oh no, isGameOver becomes true. And that will stop this loop. So while not isGameOver, if isGameOver is false, not isGameOver is true, and it will continue the loop. But once isGameOver is true, not isGameOver, it flips it, makes it false, and while cannot continue when its condition is false. Does that make sense? So that's going to stop our loop and make the game end. So once we hit the left wall, we set isGameOver to true. It starts off at the beginning of the game false, of course. Game's not over yet. Once it becomes true, we'll stop our game. And that will stop this loop, this animation, and that will be that. So there's the ball. Here it is, coming in, hitting the wall. Bam, isGameOver. Becomes true. And that will stop our game. Any questions about that? Does that make sense to you? That will stop everything, all the animation, which was the draw frame function. Bam, hits the left wall. Animation stops. So that's a good game over. I think there is a way to display text in a turtle program. Maybe you can try that for your implementation. That'll be fun to learn how to do. So that is everything except hitting the paddle. Very final thing we need to do still is hit that paddle and bounce off, okay? So the very last thing, make the ball bounce off the right side of the paddle. I think the easiest way to go about it would be just like we were checking if we hit a wall, bounce if hit wall, let's make a bounce if hit paddle function. That would just make it so much easier, right? If we hit the paddle, bounce off as well. bounce if hit paddle. See how nice that would be? So if we had that, we just call it, and it would do the thing, and it would just work. So yeah, all we need to do is go and implement this now. So our job is to figure out what in the world does it mean to bounce off at the paddle. How are we going to implement this bounce if hit paddle function? We can take it to be very similar to this bounce if hit wall function. So def bounce if hit paddle kind of thing. I might have to change some offsets, so I'll just keep all those the same, and then the rest of this is something we have to figure out now. When did we hit the paddle, and what do we do if we hit the paddle? Okay, that's our final thing to figure out. And then we will have palm. So, all right, let's draw this out. Let's figure out what needs to happen when we bounce off the paddle. We have to be very precise here. So, let's see. Here is our paddle. How big to draw it right now? I'm going to need to draw several things around it. So here's our paddle. Not drawn to scale, probably. But if you remember the offsetting that we did, the stretching that we did on the paddle, this much, the new width and height of our paddle is 30 by 120. That's going to be necessary to use stuff, use that knowledge. And then the ball, once the ball hits the paddle, we're going to need to deal with that too. The ball was stretched by 2 times in each direction, and so the ball is going to be 40 by 40. Let me draw that a little bit bigger. So the ball is 40 by 40. And every single one of these guys, they're all turtles, right? They're all relative to their center. Like their coordinates are their center's coordinates. And so if we want to do stuff with them touching, like we have to worry about where their centers are, not where their sides are. That's the kind of comparisons that we need to do. Okay, so we know where the paddle is right now with the variables paddle x and paddle y, right? Wherever the paddle is, we've made sure that this coordinate, whatever it is set to paddle x, paddle y, always. This ball, wherever it is, we know that its coordinates are ball x, ball y. We've taken care to ensure that those variables are always set to where the ball is currently. Those are these variables, ball x, ball y, right? They move around. And now the question is, when in the world does the paddle hit the ball? Because we need an if statement, right? We need to be like, if this conglomeration of conditions is true, the paddle has hit the ball and we need to bounce off. So we need to figure out, when in the world does the paddle touch the ball? You could program this in many different ways, but let's say that, like, if the ball's right here, it really did hit the paddle. Let's say that this counts. Let's say that all the way up to here, like it's just touching the edge. Let's say that that totally counts, and that will hit off. Same with down here. That will totally work and bounce off. Okay? So that's going to be the range of our touching stuff. So we need to figure that out. The ball touches the paddle when? This is going to be the bulk of the work. The ball touches the paddle when? So, when in the world are these two things touching? You can talk about their x coordinates and you can talk about their y coordinates. So, when the ball is just touching the paddle perfectly, what is true about them? What is true about them? So this ball is here, and if it's just touching, that means, like, this distance is exactly what? That's kind of what we have to figure out. What in the world is that distance that would separate them perfectly if they were just touching? Well, we can figure that out. it's going to be half the distance of the paddle. That's 15, right? Plus half the distance of the ball, the width. That is 20. You see that? We know that this length right here that would separate in the x direction the ball and the paddle if they were touching, it would be 20 plus 15, 35. Does that make sense? So the ball is touching the paddle when, I don't know, the ball's x, that's the x part, right? This much. The ball's x is less than or equal to, let's say, the paddle x. So here's the paddle, and the ball is touching it when it is less than or equal to, or maybe exactly equal to, this, plus the wherever the paddle is. Plus 15, plus 20. Does that make sense? Because what x coordinate is paddle x plus 15 plus 20? It's, all right, here's paddle x plus 15, here's paddle x plus 20. It's anything on this line. Do you see that? That means it's exactly touching it. If the ball hit it and we moved it a little too far this frame, it'll be even less than that. So less than or equal to is the right move here for the x direction. Does that make sense? So that's one of the conditions that needs to be true when the ball is touching the paddle. It's not everything, because the ball might be down here and we might consider it if we just tried this. Yeah, we'd say that, oh yeah, the ball's touching the paddle right here because it's like touching in the x coordinates. We also have to consider the y coordinates. Only then do we have the full picture, right? So we want to allow the ball to be hit when it is this far up, like the distance from the center is this far up from the paddle, or like this far down, but no further. Any further and you're not hitting it. Does that make sense? So that's the next thing that we need to discover. Like, where is this? If the ball is up here, we're still touching the paddle, but any farther, we're not. So we need to consider stuff with the y's, ball y. If we are touching, like, what's the range? What is this coordinate right here? It is, well, it's the paddle's y, that's right there, plus the paddle's height, that would bring us to here, half the paddle's height, plus half the ball's height. That would give us this y coordinate. And we want to always stay smaller than that, less than in the y direction. Does that make sense? We're hitting the ball with the paddle if the ball is less than or equal to that. So go up by, start from where the paddle is. It is plus half of its height, plus half of the height of the ball. That is the topmost portion where the paddle is still hitting that ball. So the ball's y is less than or equal to, this also needs to be true, paddle y plus 60, that's half its height, plus 20, that's half the ball's height. Does that make sense? So this ball is the last ball that could possibly be touching the paddle. What is true about its y coordinate? This place right up here is, it better be less than or equal to, if it's here, it's exactly equal to, the paddle's y, which is this line, plus 60, which would bring it to this line, plus another 20, which would be that top line there. That's in the y direction. Any less than that, we're still within the range. So don't go any further. Stay less than or equal to that, and you've hit the top of the paddle, right? You're within the range. Does that make sense? We also need to chop it off on the bottom half. Like, don't go any farther than this line. How do you come up with that line? It's, of course, well, paddle's y minus 60, right? Because we're going down in the y direction, minus another 20 for the paddle's x. Okay, so the ball's y better also be greater than or equal to, like, this line. Between this line and this line, that will be exactly touching the paddle in the y. Okay, ball's y is greater than or equal to whatever the paddle's y is, minus 60 minus 20. That would give you this line, the coordinate for that line in the y-axis. Minus 60 minus 20. Does that make sense to us? Are there any questions about that computation, that calculation? Because that was very, very important. We know that the paddle is hitting the ball is touching the paddle when the x-coordinate is exactly here, right? The ball has the distance between the ball and the x direction, and the paddle is exactly this much, or any less than that. that means it's hitting it. Right? So the ball's x is less than or equal to the paddle's x plus 15 plus 20. And then also in the y direction, don't go any farther than up here. What is that offset? It is going to be, or sorry, from the paddle at least. Don't go any farther up than up to here. What is that? That is, well, half the height of the paddle plus half the height of the ball. Don't go any farther than that up there. So the y for the ball better be less than or equal to that calculation, wherever the paddle's y is, plus half of its height plus half of the ball's height. And then same for the other direction. The ball can't go any lower than this and still be touching the paddle, so it needs to be relative to the paddle's y, go down half of its height, half of the paddle's height, and go down half of the ball's height. That is at most. That's the last time it can possibly be touching the paddle, the ball. So it better be greater than that. If all three of these things are true, all three have to be true in order for it to touch the ball. Okay? If all of these three bullets are true, that means, without a doubt, the ball and the paddle have touched. Does that make sense? There's a lot going on there, a lot of calculations, but I hope you see it. Any questions about that? We need to pick the range of values that would tell us when the ball is touching the paddle, and I think we found them. So that is what we have to do. This will be our very long if statement. Okay? So let's do it. Pong.py. So bounce if hit paddle. If. All right, there's a lot of things that need to be combined here. So, I don't know. I guess we have three things. Three ideas. This can be, I don't know. This could be A, this can be B, this can be C. Condition A is the ball's x less than or equal to paddle's x plus 15 plus 20? That needs to be true. Condition B is the ball's y less than or equal to paddle y plus 60 plus 20? That also needs to be true at the same time. Condition C, all these variables will become either true or false, right? This is just one big condition. Condition C, is the ball's y greater than or equal to the current paddle's y minus 60 minus 20? So this is the lower bound for the y, this is the upper bound for the ball's y, and this is where the ball's x needs to be. Upper bound for it, I guess. In order to still be in the game. If all of those three things are true, then the ball has touched the paddle. So if A is true, and B is true, and C is true, then we have hit the ball. The ball has hit the paddle. Yay. All that we need to do is bounce off. All right? So what do you do when we hit the paddle? It's always the right side of it, right? It's always this side. Here's the ball. Pretend that this is the paddle now. If it's coming in this way, it needs to bounce off this way. What does that mean in terms of offsets? Well, the y offset doesn't change, but the x offset negates. Like the x offset was coming in this way before, and the y offset was moving it down this way. We still want to be moving down, so same y offset, but the x offset is going to be shifted, negated by 1. So now it becomes positive instead of negative. Okay? So to bounce off, what we must do is, well, first of all, let's bring everything back in. I think. Do I want to do that? I think the only issue could be when the ball has tried to move past the paddle. So let's do this idea where we rein back in the x variable if it ever went a little too far in our frame. So let's do that. Make the ball just touch the paddle in the x direction. With the x coordinate, I guess. Oh no. Coordinate. So let's make the ball's x exactly equal to this. just in case it wasn't. And then let's bounce off. Oops, 20. I wanted to delete that. And then we bounce off by negating our x offset. Whatever it was, it is the opposite now. Ball x offset equals whatever it was times -1. And now it'll bounce off in the opposite x direction. So if it was coming in, it must have been coming into the left. It was a negative x offset. Now it needs to become a positive x offset. Okay? So that will bounce it off. And in theory, this won't ever be true twice until the ball bounces off another wall. So I believe that should do it. So this condition was on the x, these two conditions were on the y, and that tells us exactly when the ball is touching the paddle. And then if we call this every frame, if we hit the ball that frame on the paddle, it will bounce it off and make sure that the animation will start shooting off the ball in the next direction with draw frame. All right? And it should come back and all work out, in theory. Ah! There it goes. We got a very bad Y offset here. It looks to be exactly going left and right. But look at how it's working. Our conditions are checking and making sure, like even right here, it still touches the bottom, ever so slightly. And we've made sure that that is true. Go any further, though, and you lose the game. Boop. That was the kind of conditions that we needed to come up with. Do you see how important that was? But it looks like we got a Pong game now. That's exciting. So there it goes. Even at the tippy top, it still works. And then, of course, if you hit it right in the middle, it's still going to work. But it's bouncing off. It doesn't all have to hit the paddle. Like there could be just a portion of it hitting the paddle. That's what we took care of in our condition. Just a portion. But yeah, I think we have a working Pong game. Like there, it only hits a little bit. And it's bouncing off properly. And it's Pong. Isn't that beautiful? And I can lose the game by just ever so slightly missing. And the animation stops because what does our loop do? It sets the isGameOver variable. If we hit the left wall, that was this kind of condition. If we ever hit the left wall, well, you can try to do everything that we did before. It's not really going to matter. And then we set isGameOver to true, which is going to stop this loop. This loop only continues while isGameOver is false. Once it becomes true, this condition is going to stop the loop. Okay, it only continues when it's true. Oh no, it's no longer true. So, yeah, that's Pong. Are there any questions about what we did? Oh, sure. The ball moving should have come from just the bouncing game, though. Oh, no. All right. In that case, yeah, let's go back to it. Let's take a look. That was this section, this bounce of hit paddle function, right? Okay. Yeah. So maybe check that all those coordinates are perfectly accurate. All those numbers are perfectly accurate. But what we did is we noticed, like, all right, if the ball is touching the paddle, what does that mean about its x-coordinate? If it's exactly touching it, it's exactly equal to, like this. The ball's x must be exactly equal to the paddle's x plus 15 plus 20. That was this offset right here. The ball's x must be equal to the paddle's x plus 15, or, yeah, plus 20. That's exactly how far away it needs to be if it's touching. And then for the top and bottom, if we want this ball way up here to be the last kind of ball that actually touches the paddle, then what's the offset in terms of the y direction? So from the paddle's current y coordinate, what is the last valid y coordinate for this ball if we want it to touch way up here? Well, it's going to be coordinate of the paddle plus half of its height plus half of the ball's height. That would be where the y of that ball is allowed to be. So it better be smaller than that. And then same for the opposite, and an opposite sign, of course. So the ball's y, if we want it to touch way down here, that's the lowest y coordinate where we want the ball to touch the paddle, then, well, relative to the paddle's y, you got to go down by half of its height, that's 60, and then down another 20 That's half the height of the ball. That's the lowest y coordinate for the ball to still be touching the paddle. So if the ball is touching the paddle, that y better be greater than that calculation. Does that make sense to us? And so these two are like reining in the y coordinates as like an upper bound and a lower bound. So we need to be within those. So we use an and to combine them. And then also we want to make sure that the x is in the right spot as well. So we combine all three of those with an and. They all have to be true at the same time if we touch the paddle. Okay? If we did that, just in case the ball tried to go a little too far, like the animation would kind of put the ball right here, that would make us think that we are touching the paddle again, potentially in the next frame. We don't want that. So let's make sure to move the paddle to just be exactly touching it again. So move the x to be right here, and then make sure to shoot off the ball in the opposite direction with that x offset change. Does that make sense to us? Hopefully hearing it enough times, it's slowly sinking in. But that is the idea, and that will give us Pong. Any other questions? Did you get it to move again? Sweet. And so, yeah, you can change your coordinates. You can change it to make it so that if the ball touches the paddle, it can only be within the paddle. Like you can't like have a portion of the ball like off the edge. Maybe you would like to make your game like that. But this makes it slightly easier, I guess. And that will stop it. It looks like an exclamation point once it hits the sidewall. Okay, so that is Pong. So let me summarize what we did. There's a lot that went on. So as usual, draw our bounding rectangle. Don't forget about that. That tells us where our game can be played. We use the default turtle. We notice that there are multiple turtles that we can have now. So we use the default turtle to draw that rectangle. We hide it so it's no longer visible. And then we bring in the paddle. We make a brand new turtle called paddle for our paddle. We make sure to set its correct direction, stretch it in the correct way, set it up in the right spot in the middle of the game board, and set up these two functions to get called whenever we press up and down. And the default turtle can listen for those key presses still. And that will move the paddle in those directions, taking care to not go off the bottom or the top with our paddle. And then we also have the ball. The ball is another turtle called ball. We stretch it out by 2 times in each direction, and we give it a random location that's on the right half of our screen. Give it a random starting direction as well with all these offsets. Make it move a little bit faster than our 2D bounce program. So I multiplied these offsets by 2 to make it move twice as fast as our 2D bounce program. That will make the length of the hypotenuse of the direction triangle the number 2 rather than 1. So it'll move a bit faster every frame, 2 units every frame. And then, yeah, forever, we're going to keep the ball, the turtle called ball, wherever ball X and ball Y is. We're going to keep on moving those every frame. We keep track of whether the game is over with our isGameOver variable. And we continuously draw a new frame by doing animation as long as our game is not over. So as long as that's still false, draw a frame. What does it mean to draw a frame? Well, it's change the turtle's location by a little nudge, by that offset. By the y offset in both coordinates, right? Because we have a 2-dimensional direction. So move the ball in its current direction. If we went a little too far and hit a wall or a paddle, we have these 2 functions to bring it back, right? So if we hit a wall, we call this function. Or we're always calling this function to see if we hit a wall. Only if we did hit a wall does it actually change anything. So we check our coordinates, like y coordinates, we'll be checking top and bottom. Wall hitting, and we want to change some of our offsets so that we start moving in the opposite direction relative to one of our axes. Okay, same for the left and the right walls. Bounce off so that you can move in the other direction for your x offset if you hit a sidewall, for example. But keep your same y offset. Keep moving up or down. It's just left or right that's changing if you hit a sidewall. And then paddle is essentially the same as like hitting the left wall. Similar kind of calculation. It's just a bit more fancy because the paddle is a bit different to a wall because the paddle only has a certain size and it has its location is relative to where we put it, right, with our arrow keys. And so we have to do this fancy calculation. It's all got to be relative. The ball, it's touching the paddle. It's all relative to where the paddle currently is. The ball's y, wherever that is, wherever the paddle's y, because they're both moving. So that kind of calculation gets a little tedious, but we figured it out. If we hit the paddle, rein it back in to make sure like we didn't go too far in the x direction, and then bounce off, just like we were bouncing off a wall by changing the X offset, okay? And so every frame, we do that. Potentially we lose the game if we hit the left wall. We change this is game over variable. And then after all of this work, moving by an offset, potentially hitting a wall, potentially hitting a paddle, we finally have a new X and Y for our ball, and we'll bounce off, okay? Go to that new X and Y location for this brand new frame that we're trying to draw, okay? Once we lose the game, once like we hit a wall and it was the left wall, that will be the last call to draw frame, because draw frame will complete, move the ball to wherever it tried to go this very last time, and then is game over is now true, which makes not is game over false, which stops our loop. Okay? That is my best explanation of this very complicated program, but we did it. We have made Pong. Are there any other questions about it? Definitely study the code, play around with it. Again, if you hold in the arrow keys, the ball moves slower. It's funny. I guess that's a cheat. And then it'll stop if we lose. Where is it going to bounce next? Who knows? So you can change the size of things. You know how to do that. You can change the color of the balls. You can add like a, hey, this is the game over. You lose kind of message. That all is possible. And I encourage you to look into that if you're interested. So yeah, I think it's very long-winded, but that was everything that I wanted to talk about. So let's go to your programming assignment. I'm not giving you the code, but you get the video still, of course. This is your final programming assignment, programming assignment 9. This will be due December 2nd at 5 p.m. So that's the last day of classes. We won't have class. That's a Friday. But next Friday, not this Friday, that's when it will be due. And yeah, just follow my steps from the programming lecture. Make the Pong game. You can change the color of the ball if you want to. But yeah, get it working and upload a video as usual. Please prove to me that you understand it and didn't just randomly type whatever I wrote. That will be something I'm looking for. But other than that, that is your program. You can add as much as you would like to that if you're interested, but the requirements is to recreate what I did today in class. Okay, are there any questions about that? That is your final programming assignment. Hopefully a nice little holiday gift. My gift to you, I already did it. All right, any other questions about that or anything else? So I believe that's everything that I wanted to talk about. So let me stop the recording.